Okay guys, welcome to week 2 of distance learning. Today for geometry is lesson 9, equations of lines. This is a lot of some things you learned in algebra, but I want to make sure that we have a really good background and real good foundation to build upon. So we're looking at what's remembering about slope. So maybe you can tell right away. So it says how can you explain that the slope is 8/15? Well, I want us to think about the fact that I'm asking you, don't forget, always put your name and date on your paper, but I'm asking you to explain what is slope. So one of the things we know that slope is that slope is the rise over the run. We also think of that, the rise being the horizontal change, and the run is the vertical change that might be happening in this graph. Okay. Another way we can state that is we can write the equation y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that's another way to talk about slope. We also have the fact that that's rate of change. In the real world, when we're talking about that rate of change, which is slope, we think of things like miles per hour, because miles per hour is a type of slope. If we were going to graph our traveling, that we went on some trip and we graphed the traveling, the miles per hour is the slope of that graph. Also, if we were going to talk about different kinds of pies, different kind of apple pies, and as soon as you figure out how many apples per pie over the different pies, well, that would be the rate of change or the slope in that graph that we might have. In this particular problem, we have these 2 points here, and we can see that we've got for the y value here of -6, and for the y value of this one, we've got +2. To find the distance between those, I'm going to always try to start over on the right and go to the left when I'm going to be doing my equations. That's what this formula is. So I'm starting over here with this 2, and I'm going to subtract the -6. Similarly, I'm going to now take, that's the change in y. I'm going to take the x's, but again, I'm going to start with this 5. Don't switch and start with the -10. You've got to start with the 5, and you do 5 minus -10, and that's going to be your change in y. That's what the little triangle means, change. So it means delta y, or change in y, change in x. And when you compare them, meaning you divide them, one compared to the other, that's slope. Another way that we think of slope, like we had here where we wrote down rise over run, graphically we can say, oh, well, I went from this point, I went all the way up this distance, and then I went all the way over this distance, and that's our rise and our run. And if we were to count these little squares, we would find that the counting of these squares is the same thing as the change in our y. And if we counted over here, and if we had this on graph paper, we counted the squares that we went over, or the units that we went over, that would be the same as our change in our x. And so that's our rise and our run, which we find is 8 and 15, which is the 8/15. So that's a bit of review of what slope is and what we know slope to be, both conceptually, that we talked about here, as well as graphically. Now let's look at some other problems where we're going to talk about building an equation of a line. We're going to be looking at an equation of a line that might be a little bit unfamiliar, you might be unfamiliar with. So let's just go ahead and start this problem. We've got this line, and it says, write an equation that says the slope between the points, that the slope between these 2 points is 2. So we're not writing the equation of the line yet. We're just writing the slope. So we're going to write the change in y over the change in x. Well, we know that that's going to be going from this point x, y, to the point 1, 3. So I'm going to do y minus 3 over x minus 1. That's my slope. This is the formula for slope, and it says it's 2, so we set it equal to 2. And that's the equation that says the slope is 2. Now, they're going to say, well, how can we change what I wrote here into this format right here? Well, if you look very carefully at it, what happened was we multiplied both sides of this equation, the slope equation, by x minus 1. And that's how we got this. So if we just took this equation here, multiplied both sides by x minus 1, you end up with this equation. So we've got this equation here, which is like that second part, and we have it. This is, what points do you know the line passes through? Well, remember when we did slope, we did y minus one of the points, and we did x minus the x for the other point. And so if you look at those, that gives you a point that is on this line. Whatever you're subtracting from x and subtracting from y gives you a point. So I'm subtracting 5 from x and 7 from y, and it needs to be the x comma y. Don't write it 7, 5. It's 5, 7. The slope is given in this equation. It's what you're multiplying right in front of the x group. Because again, if we divided both sides by x minus 5, we would have the slope formula and it would equal 1/2. So the slope in this case is 1/2. So I'm saying, all right, now that you've done it here with these numbers, let's do it instead of there's no numbers here. It's the same idea, but so what we're going to do is we're going to do the slope equation, and we're going to write a slope equation where it equals m, which means we're going to do our change in our y over our change in our x, and there's our change in our y over our change in x, and that equals slope. So that's the slope equation. But in part B it says, let's make it look like this. So what would we do? The same thing we did before. We would multiply both sides of the equation by that denominator, which is x minus h. So that's the change in x. And when you do that, you end up with this equation. So this is known as, and it says up here, the general equation. So this is a general equation for a line. It's using a point and the slope. So now we're going to use it, and it's called, this is the name of it, the point-slope form of a line. So this is different than when you're thinking of y equals mx plus b. This is a different form of a line. It's a lot easier to write because all you need is a point and the slope. And all that we require now is to say, oh, well, I'm going to have y minus the y, which is 8. And it's going to equal the slope times x minus the x of that point. So x minus -2. Why don't you pause the video and do the next two problems and then unpause it and see what we've got. Okay, so for part B we've got y minus 7 equals -7/3 times x minus 0, and for part C we have x minus 0 equals -1 times x minus 1/2. Now each one of these can be simplified. We've got a minus a negative, and that's really not the best way to write something in its simplified form. So I just want to make sure that you recognize that that could be simplified to that equation. And where I change this minus a negative into addition. For part B, well, we don't really like to say minus 0. You don't need to write anytime you're subtracting 0. So that would just simplify to -7/3 x on the right-hand side. And similarly in part C, this minus 0 doesn't need to be written. I could just write that as y, and I end up with that. But while these are in fact the simplified, this was the way we wanted to write it because we're using the point-slope form of a line. And I want you to see that we had the point -2, 8, and a slope of 4/5. We had the point of 0, 7, and the slope of -7/3. We had the point of 1/2 and 0 with the slope of -1. So those are the formats that I want us to keep in mind. So now we're going to look at this next problem, and they didn't give us the point and the slope, but we know we need 1, we need the slope, and 2, we need a point. So looking at this graph, we need to find the slope. Well, we could do rise and run from those 2 points. There's a bunch of points that are given on this line. I could do the rise and the run from here, but I could also use the rise and run from these 2 points. In fact, pick any 2 points and find the rise and the run. And I like this one. I like those 2 points because I can see that my rise is 1 and my run is 2, which means my slope is 1/2. And any of these other ones that we could have done, these ones all would reduce to 1/2. Because if you look here, this one happens to be rise of 5 and run of 10. Well, 5 divided by 10 is still 1/2. So we still have a slope of 1/2. Now again, there's all these different points. We only need one point, but we could have picked this point, which is 6, 5. could pick this point, which is 2, 3. We could pick this point here, which is negative 4, 0. We could have picked, or any one of these points. But my favorite is the one that's on the vertical axes. Now, I'm not going to call it, I know this one's called the y-axis, but I'm just really saying the vertical axis, the one that's up and down. If there's a point that I can see clearly on that axis, that's my favorite point to use, because that's the one where x is 0. So I'm going to use the point 0, 2. And now using this slope and this point, I can write the equation of the line, which is y minus 2 equals 1/2 x minus 0. This can be simplified, doesn't have to be, but it can be simplified to y minus 2 equals 1/2 x, and this is a perfectly fine way to answer the problem, though, because this shows me the point 0, 2 and the slope of 1/2. So now we've got 3 problems. I want you to pause it and see if you can find the point and the slope in each one of these. Pause it first, do them, and then start the video up again. Okay, the answers to these are A. We've got the point, I had to change this. It said x plus, I'm going to go back just a little bit here so you can remind yourself. It said x plus 4, but I needed to change that into subtraction. So when it said plus, I'm going to subtract a negative. So now I recognize that my point is negative 4, 5. And the slope is what's in front of the group of x, and that's 3/2, and so that's my slope. In part B, it didn't write it this way, but I just wrote it, it's x minus 0 in parentheses, so now I can see my point is 0, 2. Oh, this is incorrect here, because it says plus 2, but that needs to say minus negative 2. So I'm going to be changing that part so it's going to see minus. So now you can see that it says y minus negative 2, which tells me that my point is 0 and then minus 2. The slope is the 5. And for the next problem, I changed that y to y minus 0. Again, I'll just show you what I did. It said y right here. And now it says, whoops, I went the wrong way. It says y minus 0. And then I have minus 5/8. So that tells me that my point is 5/8 and 0. And my slope is negative 2. Okay. Next set of problems, from this video I made it small, so I'm only showing one part of it at a time. The instructions here says, on the first grid, create a graph. And it's really important to note here that we're not using x and y, we're using x and t. Look at the graph though, it says t is here on the horizontal and x is the vertical. We can name these axes whatever we want, we can use whatever letters we want to in this equation. So here we're using x and t, my input is t, and therefore all of my points on this graph would be in the format of t, comma, x. And that would be the format of every point, the input being t and the output being x. Okay, so I'm looking at the equation that they gave us, and even though it doesn't have x's and y's, what's in front of the input is going to be the slope. So that's the slope of the line that I'm going to have. And I'm really curious what this 2 means. What does that 2 mean to this problem? Well, let's go kind of, I would say, old school. We're going to go do this algebra 1 class, which is I'm going to make a t table. And we've got t in it this time, but remember this is input and output. So it says t from negative 2 to 7, so we could fill this out. And first I'll put the negative 2 in, and we put it into the equation, 2 plus 5 times whatever t is. Evaluate that, and we get negative 8. And so you'll see here on my graph paper, I graphed that point. Negative 2, negative 8. Okay? Now, I could put in all of the numbers, integers, I should say, from -2 to 7, but we really don't need that. We only need 2 points to create a line. And since this says from -2 to 7, I probably want to use it would be best is to use the two ending numbers for my input. So I'm going to figure out what happens when you plug in a 7. When you plug in a 7, it's 2 plus 5 times 7, which gives us 37. And once again, I'm going to graph that point. So there it is. I graph the point. So this is 7, 37. And I'm kind of eyeballing a little bit what that is. Put a line between those 2 points, and there I have my equation of my line. I see that's just slightly off. It's not the best. It didn't hit the point exactly. But then again, I kind of eyeballed this. I want to go back to this thing, though. What is this plus 2? So we've graphed it. We've done that. But in this equation, we have this slope of 5. And if we look down here, it's kind of hard to... In fact, I don't see any real distinct points on here other than the beginning and the end to find our slope. But this does have a slope of 5. Would have been easier if we had been able to graph it right on the kind of the crosshairs here, where the like 1, 5, 2, 10, and etc. And I'm wondering what is that? Well, that's where I'm going to look at this equation as a transformation. And it's a transformation of a line that has a slope of 5 that goes right through the origin. But something's been done to it. So there's the line that goes straight through, and you can see easily now it has a slope of 5 because it goes up 5 units and over 1. Looking at these numbers, went up total of 5 units and over 1 to the red line, up 5 and over 1 to the red line. What does this plus 2 do it? Well, that plus 2 is translation, means a push. Remember, shove 2 units up. Oops, I don't know. So let me show you what I mean by that. And that is that if I were to take this line and move it 2 units up, it would land right on top of that other line. So that is the idea of what it means to move it 2 units up. So let's move on to problem number 2. Problem number 2 is doing the same idea, except they've changed the letters. We're not using X and T anymore. We're using Y and T. It says Y equals. Well, again, T is my input, Y is my output, which means all of these coordinate points, anytime I do a point here, my input is T and my output is Y. Okay? So that's it changed. The Y's on the vertical. You can see that up here. Here's the Y's on the vertical and the T's on the horizontal. Okay. We've got a slope and we have this 3. We're going, what in the world is the 3? I just know that it's a plus 3. It's a positive 3. To do this problem, let's do a t-table again, and we're going to input 2 and 7, negative 2 and positive 7. We're going to use this equation, 3 minus 4t. So we're going to 3 minus 4 times negative 2, and we get an output of 11. We have 7, input of a 7. When we evaluate that, we get negative 25, which means we have 2 points to put on this graph paper. We have negative 2, 11, and we have 7, negative 25. And when you graph those 2 points and then connect them, you get this line. Right? And again, this can be seen as a line with a slope of negative 4 through the origin. It has to go through the origin. And there it is. And what we could do is we could take this line and we could just move it up 3 units. And when we translate it up 3 units, it will land right on top of the black line. So I want you to see that this equation we have here is a type of transformation equation. This last problem puts both of those together. In this problem, I'm saying I have an input and output coordinate point. 2 plus 5t is an output point, and 3 minus 4t is an output point. So I still am interested when t's go from negative 2 to 7. So this is what we're going to do this time. We're going to make 2 t-tables, because what we're graphing here is we're not graphing t's. This is a case where we are going to be graphing x, comma, y. But we need to figure out what our x and y are from these t tables. So I'm going to put a -2 into this first part here, which is my x, because that's what this is saying. This is x. Okay? So I put those in there, and I have my x's. And similarly, we're going to put them into this one because this is my y. Putting these together, here's an x, and here's a y at the same t value. So one of the coordinate points is going to be -8, 11. The other one is 37 and -25, which is going to be another coordinate point. So we've graphed the first one. Here's -8, 11, and I did kind of have to eyeball it. And the other one is down here where I did 37, -25. And again, I did the best I could in getting it down here to where it should be. And there's the equation, there's the graph of the line. So that's the end of your first video of this week. I know this is a bit long because I wanted to take you through a lot of different concepts. Have a great rest of your day, and I will see you on video tomorrow.